difference of two consecutive cubes. That means if we have 4 and 5, they are consecutive numbers, and yeah, we are evaluating their difference as cubes. So first let us see that identity, the celebrated identity b cube minus a cube. B cube minus a cube, I can express this as b minus a multiplied with b square plus ab plus b square, so plus a square. So let us see an example. First, let me pick my numbers 5 cube minus 4 cube. So I can write this as 5 minus 4 multiplied with 5 square plus 5 into 4, which is equal to 20, plus 4 square, which is equal to 16. So on simplification, we have 25 plus 20 plus 16, and that is equal to 61. Go for another one. This is another example, 2 cube minus 1 cube. So this is equal to 2 minus 1 into 2 square plus 2 multiplied with 1 plus 1 square. So here it is 1, it is a basically multiplication, it's not multiplication, it's addition. So 4 plus 1 into 2, 2 plus 1, which is equal to 7. Okay. So let me conjecture something with respect to this example. We have n plus 1 cube, right? N plus 1 cube minus n cube. It is of the form because we are finding consecutive numbers. So if n, the next consecutive number, that must be equal to n plus 1. So what is n plus 1 cube minus n cube? I can express this one as n cube plus 3n square plus 3n plus 1 minus n cube. I can cancel out minus n cube and positive n cube. So the remaining will be 3n square plus 3n plus 1. I can write 1 over here, and the remaining is 1 plus 3n multiplied with n plus 1. Okay. Now you can see we are going for two numbers, which is n and n plus 1. Assuming our n to be a and n plus 1 to be b, then the difference of two consecutive numbers, that will be always is equal to 1 plus 3ab. So you can verify, if we go for 5 and 4, we have 3 multiplied with 5 multiplied with 4, which is equal to 61. Similarly, if you are going for 2 and 1, we have 1 plus 2, 3, 1 plus 3 multiplied with 2 multiplied with 1. So that is equal to 7. So the theorem is the difference of two consecutive cubes, that will be always equal to 1 plus 3ab, and here comes the results. Now let us go for something big story. That's a big story which was called by taxi cab number. The great Indian mathematical genius Srinivasa Ramanujan Iyengar FRS and Dr. G.H. Hardy. When Ramanujan was hospitalized due to some reason, G.H. Hardy visited to see him. G.H. Hardy was a famous mathematician at the time, and he said Ramanujan that he booked a car which was the cab number was 1729, and Hardy included the number was too odd for me and it's a bad number. But Ramanujan replied from his bed, no, it's a beautiful number. It is a number which can be expressed as the sum of two cubes, because it is the most least number, because 1729, I can write 1729 as 1 cube plus 12 cube, and that is equal to 9 cube plus 10 cube. The number which possesses this property and is the smallest one, 1729, it's the smallest number. So it's a big story from the great Indian mathematical genius Srinivasa Ramanujan. Now let us see a problem. The problem is cube root of 343 plus cube root of 729 plus cube root of 4913. On factorization, I can say that cube root 343 can be expressed as 7 multiplied with 7 multiplied with 7. Of course, 729 can be expressed as 9 multiplied with 9 multiplied with 9. And we have 4913. It is nothing but 17 multiplied with 17 multiplied with 17. So the cube root of 343, for square root we are pairing with 2. Here we are coupling 3. For finding cube, we are grouping 3 numbers, 3, 7. So that is equal to 17. So here it is 7, the cube root, that is equal to 7. 300, that is equal to 7 into 7 into 7. And here we have 9 into 9 into 9. And next part we have 17 into 17 into 17. So cube root of 343, that must be equal to 7. Cube root of 729, that is equal to 9. And cube root of 4913, that is equal to 17. So the sum of these 3 cubes, that will be equal to 7 plus 9 plus 17. So that is equal to 7 plus 9 plus 17, which is equal to 33.